Welcome back. In today's problem, we want to use LTSpice to calculate our RMS voltage. In this problem, in this previous problem, we found that the RMS voltage is equal to 187.6 volts. I'm going to link this video into the top right of this video, and let's go ahead and just do that. So let's go over to LTSpice. So first of all, our current our current was given in a cosine. Normally, when we're dealing with currents and voltages, we normally write them into sine. So we want to use the sine for the voltage. Well, at this point, we did integrate the current to get the voltage. And here, as you can see, the voltage is in a sine function. If in the case that the current was a sine and then we integrate to get a cosine, we'd have to change the cosine by using by shifting it to get a sine. So with that said, let's see what our instantaneous voltage is. So our instantaneous voltage right here, we have the amplitude and we have it in a sine format. Let's go ahead and build our circuit. So new schematic, and LTSpice has an overall, but it's the same, I think. Yep. So capacitor, then voltage source, then a ground as always. Now W for wire. Normally you'd have to use function keys, and the F2. Well, the F2s and stuff is the function key. So yeah. Anyways, that's that for the circuit, and I think we had 100 microfarads for our capacitance. Let's go back. So we have 100 microfarads for our capacitance. That's 100 microfarads. Where's my U? There's my U. Then we have, wait a minute. Am I seeing right? Yeah, there we go. And then for our voltage source, going to advance, choose, as you can see, sine. We normally use sine. So our amplitude, I think, is 265 point something, 0.3. Let's go and check. How do I do that again? 265.3. Yep, 265.3. And then for our frequency, so this is omega t. So frequency is equal to, well, omega is equal to 2 pi f. No, our frequency is equal to, would be omega divided by 2 pi. So therefore, omega is equal to 2 pi frequency. So, where's our calculator? There is our calculator. Bring that up. I did punch that out. So exactly, there we go. So omega divided by 2 pi gives us our frequency. Let's go back here and put our 60 in. Whoopsie. So that's our 60 for our frequency. And then we can just click OK on that. So I think, what is that? A in figure analysis. So we're going to use a transient analysis. And our stop time will be, well, let's just use a period. Let's use one period. So that would be, so period is 1 over frequency. That is 0.0166667. So that's 16.67 milliseconds. So let's go 16.67 milli. So that is going, wait a minute. That doesn't look right. Yeah. That was a 0, not a point. Wait, not sure what's going on with that, but that should be 16.67. I have a new keyboard. Forgive me. I haven't used a number pad. But anyways, so our transient time is good. Our voltage source is good. Capacitance is good. I think it's Control R for run. Yep. And then we can click the voltage. So that is one period. Well, yeah, looks like it. Let me just see. Make sure I see what's going on. What is the time on that? Get that back over here. So that's 16.67 milliseconds. Okay, I'll take that. So now to get the average the RMS, root mean square. We click, control click on that. And as you can see, our RMS for this problem is 187.56 volts. And if we go back to our problem, we then see that it's 187.6, which this is rounded. Same thing. So there we go. This is how you would find the RMS voltage of a capacitor or whatever you want in a circuit. So you hold control and click on your trace. So the green line is our trace, and that's it for today's problem. See you in the next one. Bye.